Hello, my name's Gareth Davies and welcome to another edition of the Kiwi Astronomers. And this afternoon I have with me Alan Gilmore. Alan was previously the superintendent of the Mount John Observatory, and as he advised me just before we came on air, he was the president of the Royal Astronomical Society of New Zealand on 2 occasions. And I'm talking to you from Auckland. Alan is in Tekapo, which is very close to the Mount John Observatory, a beautiful part of the South Island of New Zealand. And it's part of the Aoraki-Mackenzie, or it's located in the Aoraki-Mackenzie Dark Sky Reserve. And there is a wonderful church there where many tourists in the good old days used to turn up and take photographs of the Church of the Good Shepherd. And even late at night, you'll find them there taking pictures of the Milky Way, which usually is draped over the top of the Church of the Good Shepherd. Indeed, there was a starlight conference there a few years back. And when we came out of the celebratory dinner at the end, it was snowing. And it started to really come down with snow. And I was taking some people home. And as we went past the Church of the Good Shepherd, with the snow coming down almost like a blizzard, there were tourists there taking photographs of the church in the snow. So yes, that village of Tekapo, and Alan will no doubt be able to attest to this, was once a very quiet little place, and now transformed as a consequence of many things, but tourism obviously, but to do the dark skies had a big effect. Anyway, enough of me prattling on. Alan, welcome and bienvenue. How are you today?
I'm very well, thank you.
All right, how's the weather down there in Tekapo?
Well, it was overcast most of the night, and the cloud burned off round about midday. And it's now a sunny blue sky, but we kind of expect from the forecast that the sky will cloud up again soon after sunset. You
had planned to go up and do some asteroid following, is that right, tonight? Was that the plan?
Yeah, we have that plan again for tonight, but we think from the forecasts that it'll do exactly the same thing again.
And what, you have time on the telescope, is that how it works?
Yeah, we get allocated a certain amount of time. We've got about 10 days on Mount John's 1 meter telescope. It's run by the University of Canterbury. And we apply for telescope time for our program. And depending on all the other applications, we get a certain amount, anything from a week to a fortnight.
Wow, 10 days. That would cost a bit of money if that was on the Hubble Space Telescope, wouldn't it?
Well, yes, indeed. I don't think anybody except the director would ever get 10 days on the Mount John, on the Hubble Space Telescope.
I heard that actually a story, I think it was Neil deGrasse Tyson was telling it, how that Hubble Deep Field, that wonderful photograph where they worked out how many galaxies there must be out there, you know, that famous photograph, the Hubble Deep Field, that in fact it was the director of the Hubble Space Telescope who was given an allocation of time. He was the one that chose to do that. And what they were saying was that had he not had all the universities who have the time and what have you on Hubble, they would never have wasted their time staring into space, into a black hole, or not, pardon my terminology, not a black hole, into a black part of space. But this guy, he said, well, let's do it, because he had no agenda. And then we had that incredible picture that emerged from the murk. And it was all down to the fact that he was the director. He was the guy who was directing the telescope. He was in charge. And he had that time and he used it, and he wasn't paying for it. So there you go. Anyway, enough aside, me prattling on as usual. Alan and I are going to have a Q&A session today. And interesting though it might be for Alan to ask me questions for me to answer them, I think it's probably better for me to ask questions of Alan. And these are not my questions. they're questions that came through to the Kiwi astronomers over the past couple of months, and they are pretty interesting, cover a wide range of topics. And Alan, self-effacing as always, has pointed out that he is an expert on asteroids, but there are so many other areas, and maybe outside what he believes to be his field of expertise. But I know that Alan, having been involved in astronomy since a little boy, has the answer to most of these questions. So here we go. And the first one I've got here, and they're from quite far afield, in fact. The first one is from Ponsonby in Auckland, which isn't it's far afield for Alan, but not far afield for me. And the question is, not one on asteroids, I'm sorry, Alan. So you have to put your thinking cap on. What causes black holes? Do they have a life cycle? Does something stop them from consuming stuff forever? And this comes from a gentleman called Vaughan Peters in Ponsonby. Alan, over to you.
Well, a black hole is an object that where the gravity is so strong that light can't escape from it. If you could squash the sun down to about something like 6 kilometers across, then the gravity at the surface of that object would be so strong that light could not escape. They were first, it's not a new idea. There was an English mathematician back in the 1750s who was playing with Newton's law of gravity and escape velocities, who suggested that there might be dark stars so massive that light could not escape from them. But the modern black hole comes from general relativity, Albert Einstein's general relativity, which links time and space in complicated ways. And Einstein showed that if you had sufficient gravity, then space would kind of close around an object. And this was a sort of mathematical novelty for a long time, but we now know that black holes do exist. Big stars, when they run out of energy, the core collapses down. And if it's more than about 2 times the mass of the sun, the exact figure is not quite sure, between 2 and 3 times, that no state of matter will stop the collapse continuing. And so it will crash right down and become a black hole. And we know of stars that are orbiting dark companions that have that sort of mass. They were discovered back in the 1970s. But we also know now that at the centers of galaxies, most galaxies have at the center a massive black hole that is millions or billions of times the mass of the sun. The Milky Way has this black hole in the center that's about 4 million times the mass of the sun. Will black holes last forever? Yes, basically they do. There is a phenomenon called Hawking radiation, which was first, the mathematics was first discovered by Stephen Hawking back in the 1970s, I think. And in principle, a black hole does radiate away energy and become smaller, but the rate of radiation is so slow that the lifetime of a black hole is many, many times the age of the universe.
Where does all that stuff go? That has always intrigued me. If it goes in, where does it go?
Well, we don't really know. It just gets squashed down to a tiny thing. We don't know of a state of matter that would stop the collapse continuing. So I don't think anybody can properly answer that question.
But what about the stars around? When you look at the galaxies, you see a brightness at the core. Is that because the black hole, that supermassive black hole at the center, is sucking all of that stuff, and they're all getting closer and closer and closer? Is that what that is?
It occurs in some galaxies like that. There's a class of galaxies called Seyfert galaxies, named after Carl Seyfert, who first studied them. And in those cases, you have a black hole in the middle, and material is spiraling around it and becomes very luminous. The stuff spinning close to the black hole is moving faster than the stuff further out. You get friction, and that heats it up. But most galaxies are just bright in the center because there's a great concentration of stars there. There are things called quasars, where a massive black hole, 1 billion times the mass of the sun, has lots of material spiraling around it. And they become exceedingly bright. The first ones were discovered back in the 1960s. And they were very puzzling because the objects were flickering over a time of a few days. And yet we knew from their distances that they were a billion or more light years away. And it was very hard to explain how such a small object could be emitting so much light, and millions of times the total light of a galaxy. And the answer is that this comes because material is spiraling into a black hole. In its whole lifetime, the sun will convert about 1% of its matter into energy. But if matter is spiraling into a black hole, about 40% of the matter is turned into energy. So they're very efficient producers of energy.
And are there, we've got a supermassive black hole. I've heard that term used a lot, and they tend to be at the center. But we have black holes all around the galaxy, or all around the Milky Way, for example. Is that right?
Well, certainly stellar, what we call stellar mass black holes that are just a few times the mass of the sun. We don't really know how big the biggest ones are, but sort of typically a few times the mass of the sun. And they will be scattered around wherever big stars have collapsed down at the end of their lifetimes.
And how many, is there an estimate on how many they think might be in the Milky Way?
I don't know the answer to that, I'm sorry. There was a suggestion that the dark matter in the galaxy, we know all galaxies have far more gravity than we can explain by the stars, dust, the gas that we can detect. And there was a suggestion that the dark matter might be objects like small black holes, but there's no evidence to support that.
Okay. All right. Well, I'm sure we'll come back in the future to talk about black holes because they're endlessly fascinating. And I know it's sort of, everybody wants to know what's going on there. Nobody can quite get their head around what it is. So let's move on. And I'm going to go further afield now. And I've got a question from West Auckland, which is a lot further away. Not so far away, not that much further away for you than Ponsonby, but a long way. There's a chap called Bruce Aitken, and he wants to know if or when the universe dies, what are the chances of it being reborn?
In current cosmology, we think there is what is being called dark energy, which is a kind of energy within the universe, which is increasing the rate of expansion of the universe. It was only discovered in the 1990s, and the current theories are that the universe will continue to expand and probably expand at a faster rate than it's currently expanding. The universe will just continue to expand, and the stars will all just separate, or galaxies will separate, get further away, and gradually the stars will just burn out. So that's the current scenario for the end of the universe.
But you and I both attended a conference, the Royal Astronomical Society of New Zealand conference, back in 2017, was it? Where a lady called, a woman called, so I shouldn't say lady because I'm not supposed to say that, woman called Katie Mack spoke. She gave a wonderful talk. And I have to say that often when I listen to astronomy talks, slightly go over my head, but this one was really fascinating, and she brought a book out, and she was talking about how the universe might just suddenly come to an end. And it's quite a long time ago, and I haven't read her book yet, although my wife's read her book. What's the title of that book again? Do you remember?
The End of Everything. The
End of Everything, which very appropriate. And basically it would just happen just like that. I mean, it wouldn't be like you see, a pyroclastic cloud coming towards you from Vesuvius. It just happens in a second. What is that all about?
I need to read the book again, or I don't think I've actually read we've got the book, but I haven't got that far. I think the idea is that the force could be kind of exponential, so it increases very rapidly at the end. But I think that a lot of this stuff is kind of speculative. It comes out of, some of it comes out of the mathematics, but we don't know what dark energy is, and we don't know what dark matter is. We've got they keep building better and better detectors, believing that dark matter is probably some kind of subatomic stuff. And these detectors are increasingly sensitive, but they still haven't found anything. So we've got these two unknowns, dark matter and dark energy. I saw a comment that dark energy is a kind of shorthand for we haven't a clue. So there may well be further discoveries to be made that will change our views on the future.
I remember she drew something up on the board, and there was some kind of like equilibrium, you know, but it was just in equilibrium, and then if something was to happen on one side, whoop, the whole thing would tip over like a life raft on the Monaco Harbour, and you'd be sunk, so to speak. And it was quite. And we talked with her afterwards, Katie Mack, and she said that she has a bit of an issue telling this to younger kids because it's a little bit frightening, and you can easily go away thinking. I mean, we all can say with a relative degree of certainty that the sun is going to, you know, get out of control in billions of years' time. But this theory suggests that, you know, before the end of this broadcast, that would be the end. So it's a little bit frightening. So there you go. So what's the chance of it being reborn? I guess we go to other.
Well, on the current theory that we've been discussing, zero, there were earlier ideas that the universe might expand to a particular size and then gradually collapse back down again and sort of restart the whole process. I think that doesn't fit with current observations.
Okay. Well, this rather neatly puts me through to another question. If I can only find it in these multitude of questions. Now, this is far afield, this question, and it's from a gentleman called Anthony Frazier in Ashland, Missouri, the United States of America. And as you and I both know, that it was Missouri. I'm speaking like a local now. Missouri rather than Missouri. Missouri is where Edwin Hubble came from. This gentleman actually mentioned that because his question is, and oh, hang on, that's not the question. Oh, well, never mind. We'll continue with this question. We'll continue with this question because it's not the one I wanted to ask. But anyway, it's an interesting question anyway. What mystery does Alan most hope the new James Webb Space Telescope will clear up? Any predictions? This is asked in the spirit of the Missourian Hubble, who arguably expanded our understanding of the cosmos more than any other person. Do you think that's right? Did Edwin Hubble expand our understanding of the cosmos more than any other person?
Well, you probably need to
careful
talk to
what
a
you
historian.
say, they carry guns in Missouri, so be careful what you and he knows where you live.
You probably need to talk to an expert on the history of astronomy to make a complete claim on that. But certainly Hubble showed for a start that galaxies, well, we knew there was what were called spiral nebula. And he showed that the spiral nebula, first of all, the Andromeda galaxy, they were actually like our Milky Way. They were made of billions of stars. And then he went on to measure the speeds of these galaxies moving away from us. He had a lot of help from an assistant named Milton Hummerson. And he showed that the further away a galaxy was, the faster it was receding. He didn't discover this. It was discovered by a chap named Vesto Slipher earlier in the 20th century. but Hubble put it all on a much more scientific footing and showed that the universe was expanding. And if you run that back in time, the universe all comes back to one place. And so that kind of gives you an idea of the age of the universe.
Right.
What was your question?
My question wasn't mine. It was this gun-toting chap from Missouri, who will be, now that you've sort of like taken the rug out of from beneath our man Hubble's feet, suggested he just codified what somebody else had.
Oh no, I wouldn't go that far. No, he didn't discover what we call the red shift. That's the shift of spectral lines in galaxies towards the red. But using the Mount Wilson telescope, which was the biggest in the world then, right. He put the whole thing on a very scientific basis and showed that the universe had a finite age.
Well, Anthony's question was, what mystery does Alan most hope the James Webb Space Telescope will clear up?
Well, let's explain first of all, the James Webb Space Telescope is about to be launched. I think they've got it scheduled now for the 22nd of December. And it's an extremely complicated space telescope. It's got, I think, 16 or 18 mirrors that have got to all unfold into one giant mirror. And it's got a sun shield about the size of a tennis court that's got to all unfurl. And so my first hope is that it launches properly and that it all unfurls properly. It will do many different things. It's going to work at infrared wavelengths, that's the heat wavelengths. It won't be working like the Hubble Space Telescope, working in optical ordinary light. And among things it will be able to detect early galaxies right back in the early days of the universe. It should be able to see planets around certain nearby stars. So there's a whole lot of things that it can potentially do at infrared wavelengths, both in the very distant universe and the relatively close by stars around us.
And is there a particular mystery that it's going to potentially resolve?
Well, I think it will give more information about the formation of galaxies back in the early part of the universe. And then close to home, it might give us a lot more information about the composition of the atmosphere of planets orbiting nearby stars. One way we can do that is when a planet goes in front of a star, we can look to see how the spectrum of the star changes as the planet moves in front of it. And from that change, we can start to work out what is in the atmosphere of the planet. So it will do things like that. But probably like the Space Telescope, you mentioned the Hubble Deep Field that was taken by the Space Telescope, which revealed a whole lot of things about galaxies that we didn't previously know, like that galaxies start off as very simple, primitive sort of looking things, and then they gradually all gather together and make the sort of big galaxies we've got today. I imagine that the James Webb Space Telescope will make discoveries like that, things that we don't even think about right now, but what will come up out of its work.
So you have a lot of, you're like all of us, really looking forward to this launch.
Yeah, it's been a long time coming. And like I say, it's an exceedingly complicated instrument. And once it's launched, it's going to be parked about 1.5 million kilometers from the Earth. So it can't be fixed. The Hubble had optical problems and astronauts were able to insert extra optics and fix it up. But the James Webb, if it doesn't unfold and unfurl properly, it can't be repaired.
Oh dear. Well, we'll talk about that again at a later date when one is launched and two it's hurtling towards the Lagrange point. So yeah, the Lagrange point. Right. So let's. I found the question now, which was a nice segue, which I've completely failed with. And this also comes from the other side of the Earth, from a gentleman called Mark Molyneux, who was in Monmouth, on the Wales and England border. When I was a kid, Monmouth was always had a big question mark whether it was Welsh as the county, that is. He's in the town, as I can see, of Monmouth, as to whether it was England or Wales. And it was you could buy stamps there when you went to the post office, Welsh stamps or English stamps. So there you go. But that seems to have fallen out. It was a big topic of discussion, and people would sort of like say somebody from Monmouth, maybe they weren't Welsh. When you're Welsh, you like to say people aren't Welsh for some reason. I'm not quite sure why. Anyway, and it's the 7th happiest place in the UK. So he's obviously a very happy chappy. And he wants to know, segueing very nicely from the question one before, what are multiverses and do they exist? And this would be the happy news in the event that our universe was to come into some cataclysmic Katie Mack style destruction. Then out of that, there would be another universe. What do you think? Multiverses?
Well, that gets very much into the area of cosmology, which I'm rather diffident to pronounce on.
Please.
But out of the Big Bang Theory, the idea that the universe began as basically a point at a quantum level, a very, very tiny object of enormous energy. Out of that also comes the idea that the phenomenon that made the beginning of the Big Bang would also produce lots of other similar little objects that also peeled off and became separate universes. The idea of, okay, that raises the question of what we mean by the word universe, but each of these universes would have its own physical properties. They wouldn't be in contact with each other. So that's where you get the multi-universe idea comes from. And but the problem with this is that there's no end to it. These universes propagating more and more just keep coming off and producing more universes. So that's where the multiple universe idea comes from. Now, this is all down at the deep theoretical level of the Big Bang Theory. And presumably there are other mathematicians who have other ideas. So it's a very technical question.
Well, segueing back to the question from Missouri, would the James Webb Space Telescope be able to clear some of that up, do you think?
Not as far as I know. It can see back as far as we've got light type radiation. The great advantage of the James Webb is that light that was emitted, say, as ultraviolet light, gets the light waves get stretched in time as they come towards us because the universe is expanding, and so light like ultraviolet light becomes infrared light. So the James Webb should be able to look back to the very beginnings of when light was being produced in the universe, but no further than that. And that doesn't occur until you've got stars. And we don't know when stars formed exactly, but it looks like there was about 100 million years between when the gas that came from the Big Bang formed and when stars actually condensed.
All right, yeah. So multiverses, that's different to parallel universe, though, isn't it?
Well, I think they're the same thing. Yes, they would.
I was thinking a parallel universe was not something where, like quantum, where this might happen or that might happen, and then in fact they both happen, and we constantly running parallel. So you step out into the street, and one part steps in onto the road, and the other part gets knocked by a truck, and the other part doesn't step onto the road and doesn't get knocked by a truck, and it's all that sort of Schrodinger's cat and all that stuff. I thought I'd throw that in, Alan.
I'm not sure. You need to talk. I can give you the names.
Google
I can give you the names of some academic cosmologists around the country who could go much better into that.
But I just want to segue back now back to Katie Mack, by the way, and to tell you that after that conference, she came up to Auckland, and my wife and I took her out for lunch. And then as we were taking her back to the hotel, I told her that I just started tweeting, and that and she said, "Oh, I use tweet extensively, and I tweet a lot." And I think her handle is Astro Katie. Anyway, so she said, "How many followers have you got?" Oh no, I think I proudly said, "And I've already got 39 followers." To which she said, and I'm getting on, so I thought I hadn't quite heard it right. She said 390,000. I said, "What?" She said, "Yeah, 390,000. So yeah. So, but I've gone up since then, since 2017. I've now got 65. 65, not
You've doubled, yes.
yeah. Hang on a second. Yeah. So yeah, take that, Katie. I've doubled. I bet you haven't doubled since then. There's lots of ways to look at this. Right, let's go to the next question. Let's see who we've got here. Oh, I'm really putting you under pressure here, because now I'm gonna. There's somebody closer to you at home, from Akaroa, and for those who are listening who are not in New Zealand, Akaroa is a settlement east of Christchurch in the South Island, and I think it was famous because the French tried to make a stand there. Always trying to make a stand, but
Right.
the Brits saw them off, comme d'habitude, and the way they went, but it still has that sort of French style. So this gentleman's called Rob Turner, and he wants to know, Alan, thinking cap on, can you explain how microlensing is done and what has been discovered as a result? And then as an additional one, which will please you, do they do microlensing at Mount John? Alan.
Microlensing happens when two objects, two stars, line up very precisely on our line of sight. And the gravity of the near star bends the light of the distant star and focuses towards us. Now, the lineup has to be very precise. So from ground-based observation, we can't see the two stars. We just see one star that is brightening up in a particular way. And the brightening goes up to a peak and then fades off again as one star crosses in front of the other over a period of anything from about 40 days to about 100 days. Now, if the lineup is really good, the brightening can be 1,000 times, but more typically it's 10 to 100 times. That's interesting in itself because it amplifies the light of distant stars. Particularly, we look towards the center of the galaxy because you need millions of stars in your imaging in order to see a few of these events a year. And so we can then analyze the light of distant stars because it's amplified. But what is really interesting is if the near star has a planet going around it, the planet can kind of distort what we call the gravitational lens. And so instead of getting a nice symmetrical light curve, a graph that goes up to a peak and then comes down again, you get extra bumps and dips in the graph. And that, by doing lots of sums on that, you can work out the mass of the planet in relation to the star. So it provides us a way of finding finding planets around distant stars, particularly stars towards the center of the Milky Way. It was suggested in the beginning when there was the idea that the dark matter in the galaxy might be caused by things like small black holes and neutron stars and small dense objects that were not blocking light, but might be found by microlensing if they drifted in front of a star. But we haven't actually confirmed that at all. All the microlensing that has been found has been stars moving in front of other stars, except for a few events where what we call free-floating planets have been found. That is Jupiter-sized planets. Jupiter's 300 times heavier than the Earth, passing in front of stars. And then we get a brightening and a fading over a few days. So that was a discovery made by microlensing. Microlensing is done at Mount John. There's a telescope with a mirror 1.8 meters across, 6 feet across. And that telescope was dedicated to microlensing searches. It's part of consortium that involved several Japanese universities, initially Nagoya University, but now several others, and 4 New Zealand universities. But that's also now that same telescope. We call it the MOA telescope, from Microlensing Observations in Astrophysics.
Clever,
that is now also being used for some solar system studies as well.
Who was it who came up with the concept of microlensing? Was it some?
Albert Einstein played with mathematics back at the beginning of the 20th century. After he came up with general relativity, he realized that you could get light being bent around stars. But the lineup had to be so precise that you would need to monitor millions of stars in order to see one of these events in a year. And that wasn't practical in the days of photographic plates and so on. But now with digital type cameras and fast computers, it's a relatively trivial job to monitor millions of stars. And I think the MOA project at Mount John is monitoring something more than 100 million stars routinely, looking for these brightening events. Which is
the sort of like #1 place for doing this microlensing?
You mean what part of the sky, or?
No, which observatory is probably the leading one?
Oh, I wouldn't like to say who's leading, but there are several observatories. Apart from Mount John, there's work being done at, I think at the European Southern Observatory, or in Chile anyway. There's another program called the OGLE program. I can't remember what OGLE stands for, but it's a Polish-American consortium. And that is also looking for microlensing, also in the center of the Milky Way mostly, because that's where you have the greatest density of stars. We're looking, in some places, we have gaps between the dust clouds and the galaxy. So we're looking along a tube of stars about 20,000 light years long. So you've got a high chance of one star moving in front of another star. There was work being done in Australia for a while. I'm not sure whether that program is continuing, and also in South Africa. The reason why it was Southern observatories is because you need a great density of stars, and the center of the galaxy, where you have a great density of stars, is in the Southern Hemisphere.
Yes, yes. Sorry, all you listeners up there in the north. It's in the south we got the greatest density. Thank you for reiterating that, Alan. Okay, let's move on. Actually, there's a question. Rob Turner has is it a great nephew? Yeah, a great nephew and a great niece. And he has had these additional questions. One comes from his great nephew, called Alex Tester. He's in Wellington, and his sister Emily, also in Wellington. And Alex's question is, after the sun gets really big and consumes Mercury and Venus, what happens after that?
Well, as the sun is expanding into a red giant, that's when its core is running out of energy, and the core shrinks right down. The sun currently is turning hydrogen into helium, and it will continue to do that for about another 7 billion years. But then it uses up the hydrogen in its core, and the core shrinks down and becomes much hotter. It's presently about 15 million degrees Celsius or centigrade, and it will heat up to about 100 million degrees centigrade. When it does that, the outer layers of the sun will expand out, so it becomes a red giant star, and it will absorb Mercury and Venus. But at the same time, it's fizzing off a lot of gas, so its mass it lessens, it becomes less massive. And that means the Earth will move into a higher orbit. The Earth will still get completely cooked, but it will move into a higher orbit. What happens after that is when the core completely runs out of energy, it collapses further down and becomes even hotter for a time. And that pushes the very diffuse outer layers of the red giant off into space. And they glow in the ultraviolet light coming off the dense central star. And so for a few thousand years, you get a rather pretty thing called a planetary nebula, where the gas is expanding out vastly bigger than the present solar system and glowing in the ultraviolet light from the star, from the central star, which is what becomes what we call a white dwarf, about the size of the Earth and about half the mass of the Sun. They're called planetary nebula because the first ones discovered looked about as big as a planet like Jupiter in a telescope. There's a whole, if you look at the Hubble Space Telescope website, there's a whole gallery of planetary nebula pictures in there.
Well, if anybody out there is lucky enough to have a unistellescope like I have, you can go out tonight, if it's a clear night, and look at the Helix Nebula, and that is a planetary nebula. They call it the Eye of God, and it is I don't know about in the north, but in the south, it's just amazing at the moment. It's truly wonderful. You see the little white dwarf at the center, and then around it is this wonderful nebulosity. It looks like a Ferris wheel. Really something special. So you don't have to have access to some wonderful telescope or be a great astrophotographer. Just need to have this. I'm not paid to market Unistellar, but I've got a Unistellar, and every time I look, wow, that is truly amazing. And there are lots of other planetary nebula. It is really, it's one of the most wonderful things to suddenly see. And it grow. I mean, they're quite faint, Alan, for the likes of us with a scope like this. They start off faint, but you know, as the picture builds up, it's really quite amazing. And yeah, I think
the helix,
fantastic.
Yeah, the helix is very big and very spread out. So it's best seen by eye in binoculars. It's rather too big for most telescopes, but you need a dark sky and a wide field of view. So binoculars are the best way of looking at the helix. There are many smaller planetary nebula that look not much bigger than, say, Jupiter or Saturn in a telescope. In fact, one is called the Ghost of Saturn. And it's quite, those two are quite bright in a telescope, but you need a telescope to see them. And they're too small to be obvious in binoculars.
Well, I'm going to go out on the next night that's clear with my binoculars, and I have a full spectrum of binoculars. And if it's better than my unistellescope, I'll send you a bottle of wine, because it'd have to be pretty spectacular to beat what I saw the other night. But I'm prepared to be amazed. I'm prepared for my binos. What size binos would you recommend?
Oh, I've seen it quite nicely in 10 by 50s. The point is the field of view. You need a wider field of view than most telescopes will give you.
My scope got it. And also, I'm talking from the center of Auckland, not from beautiful downtown Tekapo. I'm talking from ghastly, light polluted Auckland. Not ghastly Auckland, of course, ghastly, light polluted Auckland. I would say bad thing.
Whatever. Yes.
Whatever. So Planetary Nebula, everyone, if you get a chance to check them out. And what part of the sky will they find? What in the southern hemisphere? Where will you find that Helix Nebula, Alan?
I'm afraid I've forgotten. I've had it pointed. I just pressed
go to, so I don't.
Yes.
I wasn't watching.
Yeah, I'm afraid I've just forgotten where it is. I've had it pointed out to me at sort of star parties, and had to look at it, but it's not something I can call up.
There it is.
Myself.
Yeah. Okay.
Yeah.
All right. So let's get on to we're coming close to the end of our time here. Not in terms of broadcast, not the end of the universe, obviously. Emily, Alex's sister, had a question. What is Saturn made of? I've seen it through my father's telescope. There you go.
Well, the globe of Saturn is by and large made of hydrogen and helium, which are mostly gases, but they get very squashed down in the middle. And Saturn, we should start off by saying Saturn has a mass of about 80 times the mass of the Earth, but it's a very large planet. And its average density is less than the density of water. So in principle, Saturn would float if you could find a bathtub big enough to put it in.
Wow.
But the core of Saturn is probably made of ices and liquid water and some rocky stuff in the middle. There's some recent work been done on looking at tiny variations in Saturn's rings, measured by the Cassini spacecraft that orbited Saturn for about 15 years.
Oh, Cassini, yeah.
Those tiny variations give us information about the interior of the planet. And from that, they've concluded that it has a center, a core, about 50 times the mass of the Earth, which is made up of liquid sorts of materials with probably rocks slopping around in them as well.
All right. Okay. I'm just going to see one last question. Sorry, I should have been concentrating on your answer there, but my mind wandered to what the time is, and I wanted to have one last one. How about this? This is an easy question for you to answer, but it comes all the way from Malta. Malta. When I was a kid, it was famous because they got the George Cross during the war. Did you know that, Alan? I'm sure you did. Malta GC. They don't seem to sort of advertise that these days, but they seem to be very proud of it, as were we all, because of their resistance during the war.
There's a recent book by Max Hastings.
Oh, Max Hastings. Yeah.
On the what do you call it? The convoy that took vital supplies to Malta when it was under siege. Back about, I'm not sure, was it 1942? Sometime like that, which kind of turned around the situation on Malta. Did
you read that book?
Yes.
Oh, wow.
It's quite recent. I think it's been produced this year.
Well, the gentleman asking this question his name is Morgan, Brian Morgan, and it's interesting that he'd be writing from Malta with a question like this. My father was in Malta during the war. Grand Harbour Valletta. Grand Harbour Valletta. Anyway, Brian Morgan's asked the question. I've read that the Milky Way is a spiral galaxy with 4 spiral arms. In which arm is our sun presently located? You get 4? You get 4? I thought they had more than 4.
It depends how you count them. In fact, I think the recent work shows that that's work done by infrared telescopes, something like the James Webb, but much smaller, and they can look through the dust of the Milky Way. A problem we've got in trying to see the picture of the Milky Way is that there's lots of dust. Think of it like smoke coming off very old stars, like giant stars, red giant stars. And that limits our view, but the infrared telescopes can see through it. And the Spitzer Space Telescope, which operated for many years in space, analysis of that showed that, its observation showed that the Milky Way is what we call a barred spiral. It has a sort of a bar at the center, not a circular center, but a sort of elongated center. And the 2 main spiral arms come off that and spiral around. But the sun is kind of between 2 of those spiral arms, closer to one than the other. And they make up what we see as the Milky Way. So we're in a little line that's called the Orion Arm, but it's a very tiny little extension of one of the big spiral arms. So stars, the spiral arms stand out because they're places where you get concentrations of dust and gas for complicated reasons, and that dust and gas turns into new stars, and those new stars are very luminous stars at first, and so that's why spiral arms stand out. But it's not just there where there are stars. That's where the newest stars are. So you've got lots of stars all in a disk around the galaxy, so between the spiral arms.
Right. So we are, in answer to his question, in which arm is our sun presently located? It's the Orion arm, yeah?
Yeah, which is a very small arm coming off one of the other arms.
Small arm. It's got a rather grand name, though, the Orion Arm, isn't it? It's rather nice, that. I wonder what the names of the other arms are.
Well, there's a Sagittarius arm, which is between us and the center of the galaxy, the Sagittarius Centaurus arm. So the part of the Milky Way you see from Sagittarius across Scorpius to Centaurus and beyond, that's looking towards the Sagittarius arm. I've forgotten the one outside. I think that's called the Perseus arm.
All right. Okay. Oh, well, there you go. All right, Alan, we've come to the end of our time. But we've got loads of other questions, so we'll have to do this again soon. So thank you very much for your time. And I'm letting you off because I know you might want to rush out to see whether the weather forecast you had was all wrong. And in fact, it's going to be the most glorious night, and you're going to discover loads of asteroids, and you'll be the happiest. You'll be both be happy when you come back in the morning, tired but happy. So I'll let you go. Thank you very much for your time. I want everybody to know that you can hear us on Apple Podcasts and on Google Play, or you can see a video, should you wish to watch us in the living flesh, so to speak, on YouTube's The Kiwi Astronomers channel. And there is a Facebook, the Kiwi Astronomers Facebook group. And if you want to put any questions to us, you can put them on either on the Facebook group, which is open to the public, or you can go to the YouTube channel and ask the questions there. And I have a heap more questions, and all of you guys who didn't get mentioned this time, have no fear. You will be named, but not shamed. Next time, Alan and I talk about the universe and all that's out there. So, Alan, good luck tonight. And to everybody, thank you for listening. And we'll play you out now with my favorite singer. And Alan's told me that this person is also his favorite singer, which is very nice. So thank you very much. See you all soon. Bye. Take me to Callisto so I can see the stars. I want to view the Milky Way from a terraform base on Mars. From a terraform base on Mars. From a terraform base on Mars.